you had a question about if it matters whether you get t-stats that have negative sign, if that has any importance. So I have my using Excel to run regressions PDF here. So if I scroll down here a little bit until I get some results. Okay, so I'm here on page 3, I guess, and I've got here my step number 10, the first set of regression results that I have. So I've got these coefficients here. I've got an intercept, 49. I've got the negative coefficient for price, negative coefficient for weight, negative for length. And again, as far as my first step, what I should be doing before I run these regressions is to come up with a guess in my head of what I think the signs should be. So I'm trying to explain miles per gallon. And my guess is probably with the weight would have been the easiest. I would have expected that as weight increases, the miles per gallon should go down. And then kind of similar, if the length of the car increases, it's kind of a toss-up to figure out which is more important, weight or length. But you get a bigger car, I would expect the miles per gallon to go down too. Price, we've had some arguments in the past whether that could go either way. If the price of the car is higher, then you might think it's a more expensive car, and maybe people who are buying more expensive cars may not care as much about whether their car is fuel efficient. So they're like, yeah, I'm spending a lot on my car. Also, I'll spend a lot on my gas too. So I can maybe see that would be negative. So as the price goes up, the miles per gallon go down, which is the result I get here. I can see it go the other way too, because if you're going to get the Tesla car or an electric car, something like that, a hybrid that tries to save miles per gallon, tries to give you more miles per gallon, those tend to be more expensive too. So I can see an argument where as the price goes up, the miles per gallon goes up too. But anyway, I get this negative coefficient here. The standard error is a measurement of the dispersion of the data around this particular value of the coefficient. Again, what Excel is going to do is it takes all this data on miles per gallon and price and tries to figure out some relationship between these two things. And it's going to just pick this slope variable. When I think I may have done it in the lecture. If you just are running a regression with one independent variable, you can draw everything in just a regular XY graph, and it makes a little bit more sense. So the coefficient is like the slope. It's trying to figure out the slope of this line. And so you have all of these other XY points that are in this graph. And if the points are lined up very closely, then you can draw a line through data that's very closely together, and you get a slope for that. And the standard error is going to be very small, meaning that the data is all tightly compact around this particular line. If your standard error is large, then that means that, again, Excel is it's going to pick out a particular slope to give you. And if the standard error is large, that means the data is spread out a lot around this particular line. So it's kind of like, well, this is actually the best slope to give us. It's going to give me a coefficient that's a particular value. But if the standard error is large, then it tells me that, well, the data is really spread out. So even though it does give me a slope value or a coefficient value, I shouldn't have a whole lot of confidence in that. So the t-stat, the way that the t-statistic is actually calculated is it's the coefficient divided by the standard error. If I do, I'll just take this bottom one because it's a little bit easier. Negative 0.09657. It's not going to be perfect because I'm just rounding here. 0.057716. So if you can kind of see how I'm doing this, I've got a negative 0.09657 divided by the standard error gives me this negative 1.67. Ooh, look at that. So my t-stat here is, again, it's just the coefficient divided by the standard error. The reason I'm getting negative t-statistics here is only because the coefficient is negative. It doesn't mean it's bad, doesn't mean that it's insignificant if the value is negative. What tells me whether this variable is significant or not is the size of the absolute value of the t-statistic. So when I'm looking at t-statistics, whether it's negative or not, I tend to not really focus on that because, again, that's just kind of a holdover from what the coefficient sign is. What I really want to look at is, well, this one is 1.03. I mean, it's negative 1.03, but when I'm thinking about significance or not, it's 1.03, which is relatively small. I'm trying to look for t-stats that are around 2 or 1.7, 1.8, somewhere in there. So 1.03 is relatively small, and it's kind of verified by the p-value being somewhat large, 30%. Again, there's a 30% chance that the actual effect of price on miles per gallon is 0, that there is no effect of price on miles per gallon. So I see this t-stat, even though it is negative, it's still small in the sense that it's only 1.03. I have this other t-stat here for weight, which is negative again, but it's larger. It's a larger negative number, if that makes sense. It's 1.7 instead of 1.03. So it's a larger negative number. In absolute value terms, it's a larger number. And again, that's verified by the p-value being smaller. 0.09 now. So now this weight variable would be significant at the 10% level because the p-value is less than 0.1. Same thing with length. Length is a negative coefficient. I divide it by its standard error. The standard errors are always going to be positive, so you wouldn't expect to have a negative standard error where like the negative signs would cancel each other out. So your standard error is always positive. So if you have a negative coefficient divided by a positive standard error, you're going to get a negative t-stat. And again, here with length, I get this t-stat of negative 1.67, but again, I just read it as 1.67, which is kind of big, and it gives me a p-value, that's pretty close to 0.1. So it's still just barely significant at the 10% level. So again, when you see the t-stats, whether it's negative or not, shouldn't be as big of a deal for you. If you're calculating these things on your own, then again, I guess you would want to pay attention to that to make sure you're dividing the coefficient by the standard error. But if you're looking at Excel results and you see a negative sign in your t-stat, it's not a huge deal. Again, what you're looking for is just the size of the t-stat itself, the size of the absolute value of the t-statistic. So does that make more sense?
It does. One question on the p-value, if I can.
Sure.
So if we were going to say that it's statistically significant, does the p-value need to be less than 5%? Is that the threshold?
There's usually, you can sort of invent your own threshold, I guess. Usually what we would do is, I get a little leery if someone says, oh, this variable is significant. Because I would want to say, well, significant at what? At 10% level, at a 5% level, at a 30% level? The standard cutoffs are like the 10% level, 5%, 1%. So if someone just says, well, it's significant, then I would want to know a little bit more about it.
I guess I'm considering it in terms of our assignment. Like our questions are, is it statistically significant on sales? So I'm trying to reason out at what level would I cut that off?
So well, here at the previous to that, it says in your regression, you usually look for a 10% or better level of confidence. I'm already kind of giving you what the confidence level should be. So if you were to say, you say, does price have a statistically significant effect on sales? Then you'd want to know, well, is the price variable significant at the 10% level? And again, that would mean, is it, like with the weight and the length variable, is it 0.1 or less? You want it to be less than that that significance level that you're looking for. So weight and length would be significant at the 10% level because their p-values are both less than 0.1, but they would not be significant at the 5% level because they're both greater than 0.05. I said in your regressions, look for a 10% or better level of confidence. And again, that's for this particular question. There may be other regressions later on that you do that I ask for a 5% level or something like that.